Are we all set? We're going to call this binary nomenclature. Now, binary nomenclature is exactly what it says. It's a naming system, nomenclature, a naming system for compounds made of two elements, made of two different types of elements. Okay? For instance, an oldie but goodie would be sodium and chlorine. So you get sodium and chlorine. What's the ion? What's the corresponding ion for sodium? Symbol and charge. What is it? You can do this. It's right on your periodic table. You're staring at me like I'm going to tell you. What is it? What is it? Okay, but what's the symbol for sodium? Na plus 1. And what's the symbol for chlorine? Cl, right? Cl. What were we going to say, William? Cl minus 1. Now, this is a question, really, of mathematics. Listen carefully. What is the smallest ratio of sodium to chlorine where you'll get a neutral particle? What is the simplest ratio of sodium to chlorine where you'll have a neutral particle? I have a plus 1 and a minus 1. How many of each do you need to make the smallest particle that's neutral? Yes?
1.
1 of each, okay? And you're right. Just like that, 1 of each. Now, how do you name it? How do you name it?
Sodium chloride.
Sodium chloride. How do you name it? You simply write the name of the positive element and what? The negative element, IDE, right? What's IDE? What is that called, IDE? Yes? It's called a suffix. Very good, Greta. Very good, a suffix. Okay? Now, let's do one that's a little bit more involved than that. Okay? Let's do one that's a little bit more involved than that. Let's take potassium and phosphorus. Potassium and phosphorus. What's the ion associated with potassium? Rhoda, look at your periodic table. It's right there in front of you. Don't look at that. Look at your periodic table.
+1.
What is it?
+1.
I know that, but I need the symbol. I need the symbol. K plus 1. And what's phosphorus? P minus 3. So what's the smallest ratio of potassium to phosphorus? What's the smallest ratio of potassium to phosphorus? You just said 3. Like, I need a ratio. 3 what to what? Yes.
1 to 3.
1 what to 3? 1K to 1P. Well, isn't the P negative 3 charge?
Yes.
3K to 1P. Excellent. You saw it right away. You saw your mistake, didn't you? Right away. Excellent. So I need 3 of these and 1 of these. How do I indicate the number of an ion? How do I like 3 potassiums? How do I indicate 3 potassiums? By using what? By using what? What do they call them? Subscripts? You know what a subscript is? They're looking at me like I have no idea what that means. A subscript. So how would you write? How would you write it? Write it down on a piece of paper. How would you write the answer? Go ahead, Iman. You don't know? Anybody? Anybody know? No? You don't know how to write it? Well, you need 3 potassiums and 1 phosphorus, don't you? So you indicate the number of each element by using a subscript. That's a subscript. What's the subscript for phosphorus understood to be? 1. That's right. So what would the name of this be now? You write the name of the positive component. So that's going to be potassium. And then you write the name of the negative component, which is phosphorus, but with the IDE. Phosphide. Yeah, phosphoride. I know, you got to play with phosphorus and nitrogen a little bit. Nitride, phosphide, okay? So that would be phosphide. Okay? You get it? Yes? Are you with me or not? Easy? Not yet? Okay. We're going to take it very slowly. Okay? All right. Rhoda. Pick a positive ion. Any positive ion that you know. It's got to be positive, though.
Boron.
Boron. Excellent. Boron. Okay. And what's the charge of boron? +3, right? Okay. So how would you write the symbol for boron? Just B, right? Okay. What's the symbol for boron, everyone? B. Just B, right? Now, what do you write as the charge? +3. All right, pick a negative ion, Laura.
Oxygen.
Oxygen. Excellent choice. Excellent choice. What's the symbol for oxygen, Iman? O. 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 Like in what? O? Or the letter O? The letter O. Now, is it a capital O or a small o? It's a capital O. Oh my goodness. Absolutely. So it'd be O. And what's the charge of the oxygen ion?
-2.
What is it?
-2.
-2. Excellent. Now, here you go. You ready? Okay. If you have uneven numbers like 2 and 3, 3 and 4, 3 and 5, 4 and 5, what do you do? Think of it this way. Think of it this way. You ready? Alyssa, you ready for me?
Yeah.
You ready? Okay. Think of it 1/3 plus 1/2. Think of it like that. Think of it like that. If I'm going to add 1/3 and 1/2, what's my least common denominator? 6. What did I multiply 3 by to get 6? 2. What did I multiply 2 by to get 6?
3.
You see that? You multiply one by the other, see that? Okay, yes? All right, good. Now, this is least common denominator, but I want to change that. Do you know what the LCM is? Do you remember that in math? LCM? I taught 7th grade math many years ago, and we spent a lot of time on LCM. What's LCM? Least common multiple. Very good. And what's the least common multiple between 3 and 2? You don't know? Wait a second. If I said to you, what's the least common denominator between 1/3, and 1/2, what would you say? 6, right? Isn't the least common denominator the same thing as the least common multiple of the denominators? If I said to you, with 1/2 and 1/3, what's the least common multiple of the two denominators? Would you know the answer to that question? Of course. So I'm asking you now, what's the LCM, or the least common multiple between 3 and 2? 6. How do I multiply, what do I multiply 3 by to get 6? 2. So, and what do I multiply 2 by to get 6? 3. Now let's examine to see if that's correct. What is, I have over here, I have B203, right? And do you see that I have a positive component and a negative component? Do you see that? On the left I have a positive component, and on the right I have a negative component. Do you understand? Yes or no? Excellent. Now, what's the total positive component? If each boron is +3, and I have 2 borons, what would the total positive component be? What is it? What is it? +6. So this will be +6. Excellent. And what would the total negative component be? -6. So let me get this straight. I used a ratio of 3 borons of 2 borons to 2 oxygens to come up with the least common multiple of 6. Is that the smallest ratio?
Yes.
That's the smallest combination to come up with a least common multiple, whereby the total charge is 0. You see that? Yes? All right. How would you name that, Alyssa? Well, you name the positive component. What's the name of the positive component, Greta? Boron. What's the name of the negative component?
Oxide.
So put it together.
Boron oxide.
Boron oxide. Easy? Boron oxide. Yes? You with me or not? Yes or no? Yes? Okay. Shall I show you what I want you to do for homework? Okay, you make up a table, okay? You make up a table. And on the top of the table, you put it into okay? Now this is how you do it. You ready? You write down positive components on the top. You go sodium, you go magnesium, you go aluminum, and you go, what else? Lithium. I'm going to let you go in a second, okay? And then on this side, now you know what? I screwed up. Let's put up here, let's put down here positive components. Sodium, magnesium, and we'll say boron. Is that okay?
Yeah.
And here we're going to put chlorine. What else are we going to put? Sulfur. Oxygen. And bromine. All right? Now, I want you to put in the symbol, the formula for each. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Shall we do one? Shall we do one? All right, what would magnesium and sulfur be? What's the formula for magnesium and sulfur? +2, -2, right? You get it? You get it? Go.